Chemistry 2.1, Nature of Substances and Chemical Reactions, the foundation to your paper. The key below represents atoms of some elements. So it's giving you a nice key. Use the key to draw a diagram to represent a molecule of nitrous oxide. It's giving you the chemical symbol for it. So we've got 1 oxygen, 2 nitrogens, and like I always say, lone element in the middle, and then you've got the 2 nitrogens surrounding it. Use the key to give the chemical formula for the following molecule. So we've got 1 nitrogen and 3 hydrogens. That would give you NH3. Choose from the box 2 elements from this box here. So you've got oxygen, neon, you could have picked helium as well, and 2 compounds. So compounds, 2 elements chemically combined. So you could have had CO2, CH4 or SO2. The chemical formula of nitric acid is HNO3. State how many nitrogen atoms are present in the formula. So there's 1 nitrogen there in the middle. Give the total number of atoms shown in the formula. So there's 1 hydrogen, 1 nitrogen, plus 3 oxygens. That gives you 5 overall. Question 2 then gives you a nice table, and it's talking about ionic compounds, and you're asked to name or talk about the chemicals that make them up. So sodium plus bromine goes to sodium bromide. You just change the N to a D. Sulfuric acid is asking you to name what elements are present, so you could use the periodic table to help you. It's got hydrogen, sulfur and oxygen that make it up. Final question then, to draw the formula for potassium oxide. Potassium is K+, oxygen is 2-, so you know that you've got to have an extra K to make the charges balance, so that would be K2O. Question number 3 then, again the same type of question. You've got to find 2 metals as your first question here. Name 2 metals. Metals are anything from group 1, 2, 3 in the periodic table, including them transition metals across the middle. So name 2 metals. So I put aluminium and sodium. Name 2 compounds. Compounds are 2 or more elements chemically combined. So straight away you know water's a compound. The other one there would be nitrogen dioxide. Name 1 mixture. The mixture there would be crude oil, which is a mixture of hydrocarbons. Again, a key question looking at some elements. The ammonia has the following formula, NH3. Like I said, pinpoint that lone element. Choose the letter that represents the molecule of ammonia. So you're looking for the one where you've got that lone element in the middle and it's surrounded by the other ones. So that's why that one isn't right, because it's not surrounded. That one isn't right because it's not surrounded. It's definitely A, because you're surrounding the lone element. The second part of this question then goes on to ask you to use that key. So I'll just put it by there. To use that key to then draw some other molecules. So using that key, so oxygen, so O2, so 2 oxygens stuck together, and then a carbon dioxide one, which is 1 carbon and 2 oxygens. Again, can you see that that carbon is that lone element in the middle? The chemical formula of sodium carbonate is Na2CO3. State how many carbon atoms are present. So you've got 1 carbon atom there in the middle. Total number of atoms shown in the formula. So you've got 2 sodiums, 1 carbon and 3 oxygens, all combined together to make 6. This question then is quite similar to another question on the paper. You're again looking at the elements present, maybe naming them, or again looking at the ionic formula. So the first one, complete the table. So what elements are in this? You've got calcium and chlorine. What is the name of copper and oxygen added together? That's copper oxide. And then what's the formula for magnesium bromide? And again, you can see I've worked out the charges. So magnesium is 2+, bromide is 1-. So you need 2 bromides to balance it out to make an overall neutral compound. Another key question, so CO2 is represented like this, is asking you to work out which ones it would be. So carbon's obviously going to be the lone element in the middle. Oxygen's going to be the 1, 2, because you've got 2 oxygens in carbon dioxide. It then asks you to go on and draw a key to represent a molecule. So draw a key to represent the molecules. Again, Oxygen is the lone elements, put oxygen in the middle. Carbon is the lone elements, put carbon in the middle, and then just draw them as best you can. Question number 5, quite similar again. As you can see, the space filler question comes up every time. So again, this represents oxygen, that one represents hydrogen, just got to draw it out, and then give the chemical formula a name of the molecule represented by the following diagram. So it's got 1 carbon, 2 oxygen, so the formula would be CO2, so you're just writing out exactly what you see, and then you should know that the name then would be carbon dioxide. Finally then, a question about separating mixtures. You might be asked at any point of separating mixtures, but the one that gets asked most often is chromatography. So chromogram of an orange felt tip pen was compared with various orange inks A, B, C and D. The results are shown below. Give the letters of the 2 inks that are mixed to make the orange felt tip pen. So here's the orange felt tip pen here. So it's got 1, 2, 3 inks that separate it. You're then looking for what colours make up these inks. So as you can see, I've drawn lines across, and then I've worked it out. So I've done ink A, although it matches up once, there's 2 inks that don't match there, so I've crossed it. Ink B, it's only got 1 in it and it matches, so I've given it a tick. Ink C, it's got 1 that matches and then 1 that doesn't match, so I've given it a cross. And then ink D, it's got 2 that match. So the only 2 inks that help make up the orange felt tip pen properly without having extra inks are B and D. Give the letter of the ink which contains the most soluble substance. The most soluble one means the one that travels the furthest, so that would be C, closest to the solvent front. And then RF value is given by the equation. And they give you the equation. Calculate the RF value of substance B. So you don't even need to even get your ruler out, because it gives you a ruler on the side. So it gives you how far ink B's moved and how far the solvent front has moved. So you just do 4 divided by 8 equals 0.5. And that is the RF value, how soluble something is.